Imagine spending your entire life searching for something you know is there, but you can't see, touch, or even directly interact with. That's the story of the hunt for dark matter. Although we know dark matter shapes our universe, it remains one of the most elusive substances in all of science. But scientists are determined to find it. In today's video, we'll explore how researchers are using cutting-edge technology to try and detect this invisible matter. Welcome back to TerraNova. First, let's quickly recap why dark matter is so difficult to detect. Dark matter doesn't interact with light or electromagnetic radiation, which means it's invisible to our telescopes. It also doesn't seem to interact with normal matter in any way except through gravity. But its gravitational effects are clear. It holds galaxies together and shapes the universe's large-scale structure. So how do we detect something we can't see or touch? One of the most promising ways to detect dark matter is through what's known as direct detection. This method focuses on searching for weakly interacting massive particles, or WIMPs. If dark matter is made of WIMPs, these particles should occasionally collide with regular atoms, producing tiny signals that we can detect. To catch these elusive particles, scientists have built massive detectors buried deep underground. Why underground? Because down here we can shield the detectors from cosmic rays and other particles that could create false signals. Some of the leading direct detection experiments include the Large Underground Xenon experiment in the United States and the Xenon 1T experiment in Italy. These detectors are filled with liquid xenon, which lights up when a WIMP particle interacts with it. So far we haven't caught any WIMPs, but these experiments are pushing the boundaries of what's possible in particle detection. While direct detection experiments are focused on capturing dark matter particles here on Earth, indirect detection takes a different approach. It looks for signs of dark matter interactions in space. Some theories suggest that when two dark matter particles collide, they could annihilate each other, releasing energy in the form of gamma rays or other high-energy particles. Space-based detectors like the Fermi Gamma Ray Space Telescope are scanning the universe for these high-energy signals. If dark matter is annihilating in certain regions of space, such as near the centers of galaxies, we might see a glow of gamma rays that we can't explain through other means. Though we haven't found definitive evidence yet, indirect detection remains one of the most exciting avenues in the hunt for dark matter. By searching for dark matter's footprint in space, we're hoping to learn more about its properties and behavior. Another way to search for dark matter is to create it, or at least try to, by smashing particles together at incredibly high speeds. This is where the Large Hadron Collider, or LHC, comes into play. Located at CERN in Switzerland, the LHC is the world's largest and most powerful particle accelerator. When protons collide at nearly the speed of light, they produce a shower of subatomic particles. If dark matter particles are created in these collisions, they won't be directly detected, but we'll see their effects, like missing energy or momentum in the aftermath of the collision. This missing data could point to the creation of dark matter. While the LHC hasn't discovered dark matter yet, it continues to push the limits of particle physics, bringing us closer to understanding the fundamental nature of the universe. While WIMPs are the leading candidate for dark matter particles, they're not the only possibility. Some scientists are exploring alternative theories like axions, ultralight particles that could also make up dark matter. Experiments like ADMX, the Axion Dark Matter Experiment, are specifically designed to search for these hypothetical particles. At the same time, new technologies and next-generation detectors are being developed to increase our chances of finding dark matter. From more sensitive underground detectors to space-based missions, the future of dark matter research looks promising. As our technology advances, so too does our ability to finally uncover the true nature of this invisible substance. Whether it's buried deep underground, floating in space, or colliding in a particle accelerator, the hunt for dark matter continues across the globe. We've built some of the most advanced technology in human history to try and detect this elusive substance. But the question remains, will we find it in our lifetime? What do you think? Could the discovery of dark matter be just around the corner? Or will it remain a mystery for future generations to solve? Be sure to like this video and subscribe to our channel for more explorations into the mysteries of the universe. In our next episode, we'll dive into one of the most fascinating questions in cosmology. What happens if we never find dark matter? Join us as we explore alternative explanations for the universe's hidden mass.